Okay, so this is the start of the exam feedback for the 2018 Evolution of the Living Earth exam. So there'll be a number of videos for this exam, one for each of the questions from my parts of the course. So this first video will cover the first question of part B, so that's probably question C from the exam, but we'll just start off with some kind of general advice from that covers kind of all exams really. So just yeah, I'm going to appear in the corner just to I'm watching you kind of weirdness anyway, and also to be a kind of a record of the beard. Anyway, right, so just I've given this general advice before, so it may sound familiar if you've watched other exam feedback videos. So it's great to look at past exam papers, but the questions do occasionally change every year. So be aware that just revising past exam questions is not going to be sufficient. So you have to look through the whole course and kind of think about kind of what are the key points that are being got across in each part of each lecture, and what kind of questions you think might be answered. And it's a good idea to think about what those questions might be. You could maybe post some of those questions you come up with to the discussion forum, which we have on Learn, and see if, you could ask me, is this a kind of a good question? Does this cover kind of this part of the course? And then you could maybe write an answer to that question, and I could comment on it. There's been lots of opportunity for you to get some feedback on how well you're learning stuff. So, please feel free to use that, when it's available to you. That's not a click face. There we go. Why is that? There we go. Yes. So again, just general exam advice. So really pay attention to what the question is asking you, not what's just what you've learned. And I guess that's not a great way of putting it, but the questions are asking specific things. You should address those specific questions in your answers. You shouldn't just think, oh, this is a question about this topic, I will just write some things about that topic. Because although that may be relevant, it's not directly answering the question. So some of those things might be good to add to your answer once you've answered the specific question. But if you if you just put random stuff down in your answer, you will not get super high marks. So yeah. So again, so this year, and I think last year as well, I've put together these tutorials which kind of go through this kind of reading comprehension exercise, reading an exam question, rewriting it in your own words, just to make sure that you understand what we're trying to get at. So throughout these videos, I've tried to also include a little bit of kind of decoding of the exam question. You'll see. So there'll be the question, and then underneath the question there'll be like, this is what I mean. Okay, so we'll hopefully do that. So the mark distribution for the whole exam, you can see some people answered some questions very well. There's some very high marks for some parts, and not so much for others. So if you're one of the people that got the low marks, then hopefully these videos will show you where you could have improved, and even those of you that scored the super highness, there may be points where you maybe could have a little bit better, which would be great. So this is these are the marks for the parts of the course which I taught you. So these are the climate parts in section B, so questions 3 and 4, and the biogeochemical cycles in section D, which is questions 7 and 8. Overall, similar marks for all of the parts. Again, a lot of people missing out on easy marks at the bottom end of the scale. So hopefully these feedback videos will help with future revision for resits or exams of other subjects. Right. So. Like I said, so this video will have some feedback for question 3, which is the first question of the environmental change kind of section of the exam, and there'll be another video for part for question 4, which is about the orbital variability of the Earth and whatnot. So the first question we'll go over kind of now, just another thing here, the distribution of the environmental change, just to point out that there's room for improvement for all of you in these questions. So this first question is one about climate forcing and internal variability. So this is an image from I think from NASA, which shows an El Nino event, and you'll see where this becomes potentially relevant to the question. So here are here's the breakdown of the different parts. Again, think about looking at the mark allocation for each part of the question. So there are 3 parts. The first 2 parts are quite low in their mark allocation, whereas the vast majority of the bulk of this question is in part C. Now, it might be that the way that you answer the question, you actually included some things which I was expecting to see in part C, in part A or part B. I'm not too worried about that, as long as, I mean, I'm more worried that you know the stuff and you demonstrate competence rather than put it in the right place on the exam script answer. Anyway, that being said, the bulk of the marks here are given for part C. So these are the parts of the question which you should be spending most of the time in the exam on. Okay, so looking at the first part, so describe an example from a time in the past when the Earth's climate changed due to an external forcing. Okay, so a few things to pick apart here to start out with. I guess first of all, we really need to define what a climate forcing is before you can answer the question, and specifically what external means in the context of this climate forcing. Okay, and then to answer the question, we need an example. Now, it's a lot better to be specific with your example than to be quite vague. So, for example, if there was a forcing of, say, a volcano. Say volcanoes are a climate forcing. Okay, well, that's great. But which volcano, when, how did it change climate? Okay, those extra details would have been appropriate. Okay, so before we move on and have a look at some of the details of this question, I think there was a little bit of a confusion with some of you with how you with what you thought an external forcing was. So quite a lot of people wrote an answer of an asteroid, meteorite kind of thing impact. Now, that is an external climate forcing, but it's not because it's a thing from outside of the Earth. So in the context of climate forcing, an external forcing is a forcing of climate which is not dependent on the state of the climate at the start of the forcing. So meteorites are an external forcing because they are not dependent on climate. Volcanoes are an external climate forcing because whether a volcano goes off or not is not dependent on climate. Although it kind of is, but that's for another kind of course, maybe in the 4th year, when you find out that maybe climate does have a control on whether a volcano goes off or not, or volcanoes in general. But anyway, or the position of continents. So the position of continents is not dependent on climate, but can force climate. Okay, so these are things from the past which have changed, which are not dependent on climate, which have changed climate. Now, just as a little aside, quite a lot of you who wrote about the meteorite impact, presumably did that because you were also revising for one of Steve's questions. It's totally okay, being efficient is great, but quite a lot of you wrote about a meteorite at the end of the Jurassic, and there's just not evidence for that. I think what you meant was at the end of the Cretaceous, but just, if you're going to give examples, be right. Anyway, so moving on, what are some of the examples we could use for this question? So there we go. So for example, from one of the first lectures, the change of the power of the sun. So over very long geological time, billions of years, the power of the sun has changed, and that is a climate forcing. Okay, so forcing the climate to be different. It's not dependent on climate. It is an example which is both external to the climate system, but also external to the planet. Okay, but that external to the planet thing is not important. The important thing is that it's not dependent on climate, so it is an external forcing. So we can think of lots of examples. We didn't need to think of lots of examples. We're only really asking for one example. But any forcing which changes any of the parameters in this equation, changes the solar flux, changes the albedo, the reflectivity of the planet, changes the emissivity. So an example which is emissivity related is that over the last 60 million years, there's been a change in the rate of volcanism. We've had a higher rate of volcanism going off in the past, and that's been declining. We have evidence from that from mid-ocean ridge spreading, but that change in volcanic flux has changed the CO2 concentration in the atmosphere. Okay, so for this part of the question, you wouldn't need to go into the details of how that has happened. That's for part C, but something along the lines of over the last 60 million years, the rate of volcanism has declined. This has led to a climate cooling. That would be great. Okay. You could similarly, another volcano example, but in this case, it's the opposite forcing. So it's not over the very long time scale of if we change the rate of volcanism over millions of years, we change the amount of CO2 in the atmosphere. But on a very short time scale, it's the aerosols that are given off by volcanoes which can affect climate. So this is an example which we can be very specific about. We can say a particular volcano in a particular year caused a particular climate cooling because of the sulfur aerosols given off by that volcano. And this is an external climate forcing, although it's happening on the Earth, it's external because this eruption was not caused by a change in the climate. It was caused by volcano-y processes, which you will have learned from Earth dynamics, which we all, know and love. Oh, that was too far. Again, we could go into some of the mechanisms, but that really is stuff which could be parked into part C. So part B, just like part A, is just asking for an example of a particular kind of thing that changes the climate. In this case, we're looking for a change, an example from the past that caused was a change in climate that was caused by internal variability. So I guess we could start out with the question, what is internal variability? What does that mean? Okay, and I think this is quite a lot of you got a little bit confused in that you had assumed that the external forcings has to be from outside the Earth, therefore internal forcings is anything that changes the climate that happened on the Earth. So that's wrong, didn't get any marks for that. But you did get marks for explaining the mechanisms in part D of your wrong answer to part B. So yeah, see, I'm not completely, I'm the mark hoarder. I do give out marks occasionally. Anyway, so examples of climate internal variability. These are things that change the climate of the Earth, but are not caused by any particular forcings. They're just they're caused by the climate system itself, switching backwards and forwards between stable states, which is not caused by any of the forcings. It's not caused by an initial CO2 change or a albedo change or a solar flux change. It's just the climate just changes, wobbles backwards and forwards between warm and cold for some reason. Okay, so we need to think of an example of this. I wonder what I could be talking about from the first slide from this video. So the El Nino system, which we covered in the latter part of this part of the course, is an example of this. So this is where the climate oscillates between being kind of in the El Nino or La Nina state, where in the Pacific, warm water is moving around, and this has an effect on the global temperature through a variety of feedbacks and connections within the atmosphere and ocean system. So in this case, for this part of the question, you could just say El Nino. Just that word would have got you, those two words, I guess it's two words, would have got you some marks. You could have given a little bit more detail about how climate changes or over what timescales, but just an El Nino. Another example, which I haven't got a slide for here, is the salt oscillator during glacial times. This is when the atmospheric the ocean circulation in the North Atlantic was switching on and off as it kind of like melted ice from Greenland, and that kind of led to water runoff, and that made the surface water more buoyant, less likely to sink, and then it makes it kind of colder, and then we get this kind of like switching between circulation modes where deep water is forming, transporting heat up to the high northern latitudes, and then that then leads to a cooling, and then it's explained in the lectures. So that could have been an example. So moving on to the last part now, because this was the part of the question which had the most marks allocated to it, it's kind of most of the credit comes here. We're really looking for quite a lot of detail. Okay, so we're looking for you to describe the mechanisms for each of your examples. So when we're talking about describing the mechanisms that cause climate change, things that would be good to include in that answer are things like some of the equations that are relevant. Okay, so if you're thinking about something that's changing the surface temperature because of a change in the albedo from adding aerosols to the atmosphere from a meteorite impact or from a volcano, or if we're changing the emissivity of the atmosphere through adding CO2, we could think about, well, that changes the emissivity, therefore changes the surface temperature. And we could use this equation to demonstrate that. Using the equations to demonstrate it is good. Likewise, if you're thinking about what is the mechanism of climate change, if it is a CO2 related mechanism, you could start to think, what are the controls on atmospheric CO2 that are relevant to my mechanism? So if you're looking at maybe mountain building events causing a drop in CO2 because of increased weathering, you could include some of the equations that show how weathering leads to a removal of CO2 from the atmosphere. So adding these things in where relevant is important for these kind of larger mark allocation type questions. So it's not just kind of the details of the equations that you need to add in, it's also the mechanisms that lead to these changes. So in the example of mountain uplift, which I just gave there, it would be good to say mountain uplift causes more weathering, therefore CO2 drawdown. You could add the equations in to show how CO2 is drawn down by weathering, but you could also add in more details of how mountain uplift leads to there being increases in weathering through increases in surface area through physical erosion. So having these details of all of the steps in the mechanisms is important to get all of the marks, which, everyone wants all the marks. It would be nice. Okay. Now, in addition to those kind of forced aspects of the change, so there's each of these mechanisms which you will have occurred in the climate system will lead to some feedbacks which will either moderate or amplify your initial changes. So you could have also included those in your answer as well. That would have been good. That would have been kind of taking kind of not necessarily to the next level, but would have kind of added relevant information to your answer. If you'd have just stuck in with kind of feedbacks without any of the initial forcing mechanisms, then that wouldn't have been so good. You needed to have that first and then have the extra add-on details of having some feedbacks playing a role in determining the final climate change from your initial forcings. So hopefully that gives you some idea of what we were looking for in that question 3, and hopefully gives you an idea of like from where you were in the mark scheme or what marks you got. Feel free to come to the exam feedback session and you can find out what marks you got for each question. I think on when your exam results get posted, you only get the overall mark for the exam. So if you come to the exam feedback session, you can find out what you got for each question. And hopefully this video will help you understand why you were where you are on this kind of scale and how you could have maybe improved to be more to the right. More to the right. Camera swiping things around. Anyway, so do watch the other videos, especially the question that you answered, ones for the question you answered. If you answered more of my questions, look at the videos for those. Or even if you didn't, look at the videos for those, because that might also help you, with learning, which would be good. Right, this is, it's going to start recording now, so stop it.